For as straightforward as they are, there's a lot of mystery to sewers. They're mostly out of sight, out of mind, and ideally out of smell too. But there's one familiar place you can get a hint of what's happening below your feet, and that's the manhole. Sanitary engineers know there's actually a lot of complexity in this humble hallmark of our least glorified type of infrastructure, so I set up a see-through sewer system so you can see what's happening inside. I'm Grady, and this is Practical Engineering.
So I'm interested to hear what this is about. I haven't thought about it too much. I'd say, if anything, the first thing that comes to mind when I think of a manhole cover is basically, I think this was a Google question, if I'm not mistaken, of why is a manhole cover the shape that it is? Like, why is it a circle? And so I think this was one of their kind of trick questions back in the day to see how the person thought about the problem. And so that was at least the first thing that came to my mind. But again, being from a software engineering background, I don't think so much about these things. So I'm curious to see what he's going to share.
There are lots of kinds of manholes. If it's a utility of any kind and you put it underground, there's a good chance you'll need some access to it at some point in time. But I figure if you picture a manhole in your head, it probably leads to a sewer system. Either a sanitary sewer that connects to your drains and toilets, a storm sewer that connects to storm drains, or a combined system that carries it all. Unlike what you see in movies, most sewer systems aren't huge tunnels full of totally tubular turtles and their giant rodent mentor. They're mostly just simple pipes sized according to the amount of flow expected during peak periods. Sewer networks have a tributary structure. Gravity carries waste along downward sloping pipes that converge and concentrate into larger and larger lines, like a big underground river system, but grosser. Terminology varies place to place, but in general it goes like this. Pipes that service individual buildings are usually called laterals, and those servicing particular streets are branches. Larger pipes that collect wastewater from multiple branches are called mains or trunk sewers, and the most significant lines furthest downstream in the system are usually called interceptors. And connecting each one is a manhole. This is my model sewer system. I'm just pumping water into an upper manhole and letting it flow through the system by gravity. I chose to do this with nice blue water for anyone watching while having lunch. In real life, the color in a sewer line isn't quite this nice. Unlike regular plumbing where you use fittings to connect lengths of pipe together, sewer lines are connected with manholes. Any change in size, direction, alignment, or elevation is a place where debris can get caught or turbulence can affect the flow. So instead of elbows or T's in the pipe, we just put a manhole instead. In fact, unlike many underground utilities, you can usually trace the paths of a sewer network pretty easily because it's all straight lines between manholes. They provide a controlled environment where the flow can change direction, and more importantly, a place where technicians can get inside to inspect the lines, remove.
This is actually a pretty cool CGI thing he has going on here. I don't know if he made this himself or if this is something that he found somewhere, but it is actually very good for demonstrating how these things work. Obviously, the gentle slope is there, so that way you don't need electricity or anything else. The water just slopes in and everything just kind of goes smoothly without human intervention most of the time. Obviously, unless like a clog or something occurs. So this is definitely a technique that basically, since we've had running water as civilization, we've used some type of sloping mechanism in order to carry water with minimal effort.
Or perform maintenance, hence the name. Unlike fresh water distribution systems that can usually go a long time without any intervention, sewers are a little more hands-on. Just make sure you wash your hands afterwards. There's just no end to the type of things that can make their way into the pipes. Fibrous objects are particularly prone to causing clogs, which is why so many sewer utilities have campaigns encouraging people not to flush wipes, even if they say flushable on the package. Fats, oil, and grease, or fog in the industry, are also a major problem because they can congeal and harden into blockages, sometimes not so lovingly known as fatbergs. Of course, a lot of people aren't aware of what's safe to flush or wash down the drain, and even for people who know, It's easy to let something slide when it's not your problem anymore, and in most cases, the rules aren't very strictly enforced outside of large commercial and industrial users of the system. But if you use a sewer system, in a way, obstructions really are your problem because a portion of your taxes or fees that pay for the sewer system go towards sending people, not always men despite the name, into manholes to keep things flowing. And the more often things clog up, the higher the rates that everyone pays to cover the cost of maintenance. There's quite a lot of sophistication in keeping sewers in service these days. It's not unusual for a city or sewer district to regularly send cameras through the lines for inspection. Technology has made it a lot easier to be proactive. In fact, there's a whole field of engineering called infrastructure asset management that just focuses on keeping track of physical assets like sewer lines, monitoring their condition, and planning ahead for repairs, maintenance, and replacement over the.
So they did mention how some of these things that people do that aren't really the appropriate way of using your sewage system can lead to extra charges. I would assume that there's still a baseline level of expectation around maintenance that's going on here, especially just because since it's not just like filtered water that's going in, then naturally there's going to be some type of clogging that naturally occurs over time just due to whatever is going through those pipes. And so presumably they have a regular maintenance schedule. I'm not sure how much each individual's habits actually impact this, especially since he dedicated a good chunk of time kind of referencing that. I wish he had added some data or backing those claims. I do suspect that it's true at a high level where if individuals did these bad practices less, there'd be less maintenance, but it's unclear to me whether that's like instead of somebody doing maintenance once every 30 days, they would be doing it every like 35 days, or is it every 60 or 90 days? I think that's the scale that I'm kind of missing myself. I would assume that there is still some regular maintenance that you would do regardless of behavior of that community.
Long term. A lot of the unclogging and cleaning these days is done by hydrojetting. Basically, a pressure washer scaled up. Rotating nozzles blast away debris and propel the hose down the line. In fact, one of the benefits of manholes is that if a sewer line does need maintenance, it can be easily taken out of service. You can just run a bypass pump from one manhole to another and keep the system running. But maintenance isn't the only thing a manhole helps with. You can see a few more things in this demo. For one, manholes provide ventilation. Along with the solids and liquids you expect, gases can end up flowing through the sewer pipes too. You can see the bubbles moving through the system. Air bubbles can restrict the flow of fluid in a pipe, and air pressure can cause wacky problems like backflow. Along with regular air, toxic, corrosive, or even explosive gases can also build up in a sewer if there's no source of fresh air. So ventilation from manholes is an important aspect of the system. Sometimes you'll even notice condensed water vapor flowing up from a manhole cover. In a few cities, like New York, that might be related to an actual steam distribution system running underground. But it can also happen in sewers when the wastewater from sources like showers and dishwashers is warmer than the outside air, especially in the winter. I added a third manhole to my model so you can see how a junction might look. It just provides a nice way to confluence two streams into one pipe, which is an important job in a sewer system since a sewer shed all has to flow to one place. The manhole acts kind of like a buffer, smoothing out flows through the system. And normal flows, that's not a super important job. It's basically just a connection between two pipes. But the peak flows for most sewers, even if they're not storm sewers, happen during storms. Drains may be improperly connected to sanitary sewers. Plus, surface water often finds a way in through manhole covers and other means. In fact, a lot of places require sealed and bolted covers if the top of the manhole is below the floodplain. That's why you sometimes see these air vents sticking up out of the ground. Many older cities use combined systems where stormwater runs in the same pipes, so rainwater in sewers can be a major challenge. And you can see when you get a big surge of water, the manhole can store some of it, smoothing out the flow downstream. These storm flows are actually a pretty big problem of the constructed environment. You may have heard about the trouble with holding swimming events in the Seine River in Paris during the 2024 Summer Olympics. Same problem. Wastewater treatment plants can only handle so much flow, so many places have to divert wastewater during storms, often just discharging raw, if somewhat diluted sewage directly into rivers or streams. In fact, some of the most impressive feats of engineering in progress right now are ways to store excess wastewater during storms so it can be processed through a treatment plant at a more manageable.
Yeah, this is definitely something I don't think about on a regular basis. I'm sure many of you don't think about this on a regular basis either. So basically, those manhole segments, those larger cylinders, basically add a buffer, so to speak. So that way, the actual piping and the angles, I believe, is what determines the throughput of the pipes. And so that will stay static throughout the day and throughout various events. But by having those cylinders, it actually allows for you to kind of accumulate excess for some short period of time. And presumably, if your system is set up such that it is over capacity for standard load, then basically when these severe scenarios are done, then you basically start to remove some of that excess over time naturally. But this is an interesting problem that they're highlighting, which is like during severe weather, etc. What happens when they're basically at capacity and still that isn't enough to handle all the excess? And so this is interesting. I haven't seen one of these environments before. It is also interesting that it's like right in between these other waterways and like this highway here. It appears to also be uncovered. I'm curious if there would have to be other structures around here to potentially treat that extra waste, or if they literally just have it kind of appear here. Presumably if there's flooding due to like rain or severe weather, then potentially it would just be diluted naturally through the rain and the weather that is occurring around it. But it also seems odd to me that you would just literally funnel it into this pool without doing anything else to it.
Rate, but overflows can also happen way upstream of a treatment plant if the pipes are too small. Sometimes that storage available through manholes isn't enough. I can plug up the pipe in my demo to simulate this. If the sewer lines themselves can't handle the flow, you can get wastewater flowing backwards in pipes. And if things get bad enough, you can get releases out of the top of manholes. And of course, this doesn't have to be the result of a storm. Even a blockage or clog in the line can cause wastewater to back up like this. Obviously, having raw sewage spilling to the surface is not optimal, and many cities in the US pay millions of dollars in fines and settlements to the EPA for the contamination caused by backups. Another thing this model shows is that not all pipes have to come in at the bottom. They call this a drop manhole when one of the inlets is a lot higher than the outlet. The slope of a sewer line is pretty important. I've covered that topic in another video. There's a minimum slope to get good flow, but you don't want too much slope either. Wastewater often carries rocks and grit, so if it gets going too quickly, it can wear away or otherwise damage the pipes. So if you're running a line along a steep slope, sometimes it's a better design to let some of that fall happen in a manhole rather than along the pipe. It's not normally done this way where my pipe just juts in. You usually don't want a lot of splashing and turbulence in a manhole, again to avoid damage, but also to avoid smells. So most drop manholes use pipes or other structures to gently transition inlet flow down to the bottom. I hope it's clear how useful manholes are by now. Doing it this way, by making the plumbing junctions into access points, just provides a lot of flexibility, while also kind of standardizing the system so anyone involved, whether it's a contractor building one or a crew doing maintenance.
I really appreciate how he does these demos once in a while for showing you and demonstrating various mechanics of how some of these systems work at a much smaller scale. I agree. I don't think I would have appreciated how useful manholes were, especially as he highlighted sort of that like drop entry there. I could see how this evens out, especially if you're traveling over long distances or you have a variety of pipes all hooking into the same system. They aren't necessarily going to all be level at that exact point, especially because you want all of them to be sloping. So this does give some wiggle room to it and the extra storage in those severe cases. So it was actually really nice to be able to see that here.
Kind of knows what to expect. In fact, if you live in a big city, there's a good chance that the sewer authority has standardized drawings and details for manholes so they don't have to be reinvented for each new project. In many cases, they're just precast concrete cylinders placed into the bottom of an excavation. Those cylinders sit on temporary risers, and then concrete is used to place the bottom. often with rounded channels to smooth the transition into and out of the manhole. I did a video series on the construction of a sewage lift station and showed how a few of these are built if you want to check that out after this and learn more. Constructing manholes reminds me of that famous interview riddle about why manhole covers are round. There's a lot of good answers. A round object can't fall down into the hole. It can be replaced.
It is actually pretty awesome how he referenced the question. I didn't know that he gets this question as well. Maybe this is a cross-engineering problem. But it's awesome that this came up, and I referenced that earlier. I had no idea that was going to happen here.
Placed in any orientation, it's easy to roll so workers don't have to lift the entire weight to move it out of the way. A professor of mine had an answer that I don't think I've heard before. Manhole covers are round because manholes are round. It's almost like asking why Pringles lids are round. And manholes are round for a lot of good reasons. It's the best shape for resisting horizontal soil loads. It's easier to manufacture a round shape than a rectangular one. For those reasons, manholes are usually made of pipes. And pipes are round because it's the most efficient hydraulic section. It's one of those questions like the airplane on the treadmill that can spawn unending online debate, but I like pipes, so that's my favorite answer.
Thank you for watching. If you've enjoyed what you've seen, please hit like or subscribe. I'll see you around.